Hi guys, welcome back to the channel. In this video we are going to discuss the concept of demultiplexer. So it is very similar to the multiplexer, so please refer to the multiplexer video once. So let's get started. So as we all know, the basic of multiplexer is this. So when we pass the 2 power n inputs, so basically we are going to have in that case the n select lines. For n select lines we are going to have 2 power n inputs. So how many may be the inputs, but the output would be only one. So this is known as the basic thing, that is multiplexer. But the demultiplexer means the exactly opposite thing. So we have only one input, that is in this case I have represented with a variable I. So but you have the outputs as 2 power n. So the select lines would be n. So select lines would be n and the outputs would be 2 power n, but the input is 1 always. It is exactly opposite of the multiplexer. So according to that we have many demultiplexers, that is 1 cross 2 demultiplexer, 1 cross 4 demultiplexer, 1 cross 8 demultiplexer. Here 1 means the input and the 2 or 4 or 8 represents the outputs. So I hope you can relate with the multiplexer this. And the select lines are also increasing. See, the first one we have S0, we have then S0, S1, that is 2. Then we have S0, S1, S2, that is 3 inputs. Next the 4 inputs, that is 1 cross 16 demux. So instead of calling always it as demultiplexer, we can simply call it as demux. It is exactly the similar. Multiplexer we will call it as mux. The demultiplexer we will call it as demux. So the symbol also we can represent in the box format or this trapezium format, both are same. And one more important thing, so already we have discussed about the decoder. I hope you know about decoder. So now also we are going to discuss about demultiplexer. So if you make a small changes in the decoder, then it will behave as a demultiplexer. So basically the next video is based on that only, how to implement the demultiplexer with the help of decoder, or we can simply say decoder as demultiplexer. So stay tuned for that video. It is very important concept that we should know that demultiplexer can be implemented or decoder as demultiplexer. A small change, that's it. Remaining small, all things would be same. If you consider outputs would be 2 power n, in the demultiplexer also we have outputs 2 power n. So in this we have select lines n, but in this we have inputs n, but in this we have enable e, in this we have input e, I. A little bit change is there. We can convert this, we can see in the upcoming video, but remember this in the video we can have decoder as demultiplexer. So already we have discussed in the multiplexer, the same things we are going to see in this demultiplexer also. If you consider what the 1 cross 4 demultiplexer, you can see, observe over there, we have two select lines, that is S1 and S0. So according to that we are going to select the output. So if input is 0 or input is 1, we don't care that, but the input will be sent to one of the output based on the select lines. If select lines are 0 0, we are going to send the input to D0. If the select lines is 1 1, we are going to send the input into the D3. So according to that we are going to have the output expressions also, that is if you consider D0, that is S1 bar, S0 bar and I. So remember this thing, this is multiplexer, so that you are going to multiply with the input also. So follow these things. So you have total 4 output expressions for D0 to D3. Simply as we already saw in the multiplexer, how to draw the circuit diagram. According to that we are going to follow the same output expression. If you see the D0, so S1 bar, S0 bar, I. So take S1, S0, their complements also. So we have the input I, so take that also as variable. So for the AST AND gate, we are going to connect all. Likewise only we have to connect all the remaining 3, that is D1, D2, D3. So I hope you know how to formulate the circuit diagram from the output expressions. So this is the circuit diagram for the 1 cross 4 demultiplexer. So similarly if you observe the 1 cross 8 demultiplexer, total we have 3 select lines and total 8 outputs, but we have only one input. So this is a truth table for the 1 cross 8 demultiplexer. If you observe in that we are going from 0 to 7. That is the selection, that is from D0 to D7. In the similar format, if you are sending S2, S1, S0 as 0 0 0, we are going to select the D0 as the output would be passed, or the I will be passed into D0. Similarly if you pass 1 1 1, the input will be passed to D7, like that you are going to select. So it is also a switching circuit as multiplexer. So outputs also can be obtained, that is from D0 to D7. The similar fashion, that is if you observe the first one, S2 bar, S1 bar, S0 bar and I, similar only. So similarly, if you want the circuit diagram, or if you want to know the inside the box of the 1x8 demultiplexer, just you are going to have the output expressions. According to that, you are going to have the AND gates. So this is 1x8 demultiplexer. So we have total three select lines, that is S0, S1, S2. So their complements also I took, and the variable input, that is I. So if you consider clearly this one, each term D0 to D7 having 4 input terms. Likewise, if you are having the higher demultiplexers like 1x16, 1x32, like if you have like that, you are going to have higher number of inputs in the AND gate. So in this we have 4 inputs in the AND gate. If you have 1x16, we are going to have 5 inputs and in the AND gate. Likewise, if you are having the select lines, increasing select lines, we are going to increase the complexity. We are going to have the higher logics and higher complexity, higher costs also for making the circuit. So that we are not going to use the higher multiplexers for the building of higher multiplexers. We are going to use the smaller multiplexers for the building of higher multiplexers. So let's see how to do that. Because see, the smaller multiplexers have the AND gate inputs is very low. Because if you consider 1x8, it is having only 4 inputs as AND gate. So I hope you are understanding. If you consider the 1x16, that will have 5 inputs. So for the more clarity or understanding, we are going to implement the 1x16 demultiplexer with the help of 1x8 demultiplexers. So basically we are going to use the two 1x8 demultiplexers for the formation of 1x16 demultiplexer. So let's see how to do that. So as we have the dedicated video for the multiplexers as the same thing, that is the video on basis of how to implement the higher multiplexers with the help of the lower multiplexers. If you want that video, I am giving the video in the description box, check it out. But this is the same thing that we are going to implement. So the thing that we have the select lines, that is from S0 to S2 in the same thing. So we have to cascade the 1x8 two multiplexers in this format, demultiplexers in this format. So as the inputs, the outputs also we are going to vary from D0 to D7 in the first 1x8 demultiplexer. In the second multiplexer, you can see that is we are going from D8 to D15. So we are only having the 3 select lines. The remaining 1 select line will be formulated in the. So as we have the remaining 2 inputs, we can join both of them and we can add 1x2 demultiplexer over there. So as this is the 1x16 demultiplexer, we have covered only the 3 select lines, that is S0, S1, S2 in the first cascaded thing of 2 1x8 demultiplexers. But the remaining one, as 1x16 demultiplexers contains the 4 select lines. The 4th select line is connected to 1x2 demultiplexer, that is S3. So we have total 1 input and total 16 outputs. So this is the implementation of 1x16 demultiplexer. In the similar format, if you want the 1x16 demultiplexer to be implemented with the only 1x4 demultiplexers, so that can also be done. So if you consider basic thing, so I have took total the 1x4 demultiplexers 4, because in the 1x4 demultiplexer we contain only 4 outputs. So similarly, if you want 16 outputs, we are going to have 4 such kind of things. So cascade all of them, and all of the select lines would be S1 and S0. So that I have connected the all select lines at a time. So if we have 4 inputs, we can connect the 4 inputs to 1x4 demultiplexer. So let's see how to do that. So in this we have total the 4 inputs for the 4 demultiplexers. We can join all of them and we can connect to 1x4 demultiplexer as that coming from as output. So here we have 1x4 demultiplexer. For that we are going to pass the remaining 2 select lines, that is S2 and S3. So this is 1x16 demultiplexer, we are going to have the 4 select lines, that is the S0, S1, S2, S3. So those 4 select lines are covered. So total we have 1 input and 16 outputs. If you want that only we should, so the 1x4 demultiplexer can also be changed to 1x2 demultiplexer. So that's implementation also we will see now. So this is the thing that I am saying about. For the first 4 1x4 demultiplexers, we are going to have the 2 select lines, that is S1 and S0. If you see clearly, for the first 2 we are going to connect 1x2 demultiplexer. For the next 2 we are going to connect the 1x2 demultiplexer. Again for both of them we are going to have 1 select line, that is S2. So for that also we are going to have the two inputs for the first one and the second one. So join both of them and have one cross-tumor demultiplexer. For that select line is S3. So in this format also we are going to have one input and 16 outputs, and we have covered all the 4 select lines, that is S1, S0, S2, S3. I hope you understood the demultiplexer video. So this is as similar as the multiplexer. In the upcoming video we will see in detail how to implement the other logics with the help of demultiplexer, and how to I mean decoder as demultiplexer is that video I can simply say. So I hope you understood video. Thanks for watching up to now.